Hope you are good, guys. This is the remaining questions, question 4 onward for the mid-year exam December 2024, A2 paper 3. Okay, here we have to find the gradient of the curve at point when y equal to 1, and because it's an implicit function we need to find the coordinate of x as well. So first do replace y equal to 1 in the equation. We will get this term, and it means u square will be e raised to power 2x. So it will be u square plus u minus 6 is equal to 0. So u plus 3, if we make the midterm break rule, we can factorize it. U will be minus 3 and u will be 2. So to replace the value of u here in 1, we will get e raised to power x equal to minus 3. So which is not possible because the log of negative is function is not possible, so ignored. We will ignore this value, and once we will take this equal to 2, so taking log, it means x equal to log of 2. So when y is 1, x will be log of 2. Now for the gradient we need to differentiate this one, the function, and here we will apply the product rule to twice. Let's see. So d by d of x of y e raised to power 2x plus d by d of x of y square e raised to power x, here d by d of x of 6. Here you will see we will apply the product rule, u times v, here u times v. It will apply twice product rule, so you know the rule well. So we will write e power 2x, y is dy by d of x with respect to x, plus e power 2x is 2 e raised to power 2x times y. This is the first differential result, and plus here 2y e raised to power x and dy by d of x plus y square e raised to power x, and the constant differential is 0. So it will be 0. So we will arrange all dy by dx one side and rest will be on the other side. E raised to power 2x plus 2y e raised to power x dy by d of x equal to minus, because this term and this term goes to right side, becomes minus y plus y square e raised to power x. I just took the negative common for the both terms. So dy by d of x equal to minus 2 e raised to power 2x y plus y square e raised to power x divided by e raised to power 2x plus 2y e raised to power x. Now at point x is log of 2 and y was 1, so dy by dx becomes the gradient. At this 2 log 2 comma 1, it will be m, and we'll get minus here 2 times x is log of 2, so 2 log of 2, y is 1 plus 1 square 1 e raised to power log of 2, and same here e raised to 2 log of 2 plus 2y is 1 times e raised to power log of 2. We will apply the properties of this. It will be minus outside 2 times 4 plus 2, and denominator we get 4, 2 power 2 is 4 plus 2 times of 2, so it will be minus 10 by 8, so minus 5 by 4 is the gradient. I hope it is clear. Let's go for the next question. Okay guys, this is question number 5. It is given that the equation is e raised to power 2x is equal to e raised to power 2x equal to 5 plus cos 3 of x as only one root. Show by calculation that this root lies between 0.7 till and 0.8. So first bring every term equal to 0. So all both of the right side term comes here with we can get e power 2x minus 5 minus cos of 3x equal to 0. Let's suppose this is a polynomial of x. Now for this at 0.7 I will replace 2 times 0.7 minus 5 minus cos of 3 multiplied by 0.7. Here the important point you need to keep in mind that 0.7 0.8 are the values in radian. So cos angle must be in radian. So it's better to change the mode of the calculator in radian. We will get the answer minus 0.43995. That means negative result here. And also for the other point 0.8 we will do the same, just replacing x with 0.8 by keeping in mind the mode of calculator must be in radian. So we will get as plus 0.6904. Since 0.7 polynomial results is less than polynomial 0.8, because it's a change of sign rule. Change of sign rule, we can say that the root is lying in between 0.7 and 0.8. So proved. Because the both results give us different sign, one is positive, one negative, so it's proved. Okay, the part B says if a sequence of the value of interval 0.7 less than is given by the iterative formula. We are given iterative formula x n plus 1 equal to 1 by 2 natural log of 5 plus cos of 3xn converges, then it converges to the root of the equation in part A. So whenever such kind of questions come for the convergence, we need to eliminate first these values, these subscript values n plus 1 and n, and let the term in simple order. And after simplifying this, we need to get the question as shown in the part A of the part A of the same question. Okay, here we will see. First we will eliminate these n plus 1 and n, and we will write like the same log of 5 plus cos of 3x. Now 2 comes here, 2x is equal to natural log of 5 plus cos of 3x. So taking base e on either side, we can write here 2x e raised to power log of 5 plus cos of 3x. As per rule, this will be cancelled, and we will get e power 2x equal to 5 plus cos of 3x, which is same as like part 1, which is same as part A. So proved. We have proved that this converges to the part A. Next one, C part says use this iterative formula. That was, I'm rewriting it, and plus 1 is equal to 1 by 2 log of 5 plus cos of 3xn, and to determine the root correct to 3 decimal places, given the result of each iteration to 5 decimal place. Okay, you need to write the iteration 5 decimal place, and when it start equating till 3 decimal place, then stop. So is here the initial value is not given to us, so for that case we will take initial value, say x1, that is the average or mean of the intervals value, that is 0.7 till 0.8 divided by 2, I will get 0.75. This is the x1 initial value. So here, by replacing n with 1, 2, 3, and so on, we start iteration. For when we replace n1, we will get here x2 is equal to 1 by 2 natural log of 5 plus cos of 3x1, and that gives me 1 by 2 natural log of 5 plus cos of 3, and x1 is 0.75, and I will get the answer with the calculator. I will get the answer with the calculator, but keeping in mind that the mod of calculator must be in radian, because cos of 3 times 0.75 result should be in radian. So we have to write in 5 decimal place 0.73759. This is the first result for x2. And now here you need to suppose this is suppose answer, because in the calculator it is saved in the answer once you equate it. The next you will write 1 by 2 log of 5 plus cos of 3 times answer, right? And you will equate it. Yani do write 1 by 2 times natural log of bracket 5 plus cos of 3 times answer, and you will see we will get 0.74094, right? Again, second time once you press it, only press the equal to sign from the calculator. No need to resubstitute this. We get x3, and that comes to be 0.74003. As we have to finish our answer up to 3 decimal place, you can see up to 3 decimal place 0.740 is the same with these iterations. So I will stop here. So my final route is, therefore, required route correct to 3 decimal place 3 dp equal to 0.740. That's the final answer of this question. I hope it is clear as well. Okay guys, here goes the question number 6 for the paper. The diagram shows the curve y equal to x e raised to power minus ax, where is a constant, positive constant, and its maximum point is at m. Find the exact coordinate of m. Okay, here the maximum point is the m. That is for the maximum point, find the exact coordinate of m. So for the maximum point, we need to find dy by dx and equal to 0. Maximum minimum point. So we will find dy by dfx of it by applying the product rule, x times d by dfx of e raised to power minus ax plus e raised to minus ax times dx by dfx of x. I applied the product rule of differentiation, and I will get minus ax e raised to power minus ax plus e raised to minus ax. So I can take common or equal to 0 it. I will get an e raised to minus ax common, minus ax plus 1 equal to 0. So once equal to 0, so this will be log of 0 is not possible, so ignored, and minus ax plus 1 equal to 0 mean ax is equal to 1, x will be 1 over a. This is the x coordinate of the point M. So replacing it in equation for y coordinate, y equal to x is 1 over a e raised to minus a into 1 over a. 1 over a e raised to power minus 1, 1 over a e. This is the y coordinate. So the coordinate of m are 1 over a comma 1 over a e. This is the exact solution. 5 marks question. A part done. B part says find the exact value of the integral 0 to 2 over a lower limit to upper limit x e raised to power minus ax d of x. Here we will apply the integration by parts, either by using Eilert rule, or you will take this one algebraic function as linear algebra as u and exponential as v. By using integration by parts, we'll get u integral of v d of x minus integral of differentiate of u integral of v d of x, and this. I applied the complete product rule here, or you can separately integrate this and substitute in the formula. It will be signed in the MF19 formula sheet. So it will be e raised to minus ax over minus a minus 1 times e raised to minus ax over minus a d of x. I will write minus x e raised to minus ax over a plus 1 over a integral d of x. Now this integral will be minus x e raised to power minus ax over a minus 1 over a square e raised to minus ax, and here the limit goes to be 0 to 2 over a. First apply upper limit minus lower limit, so minus 2 over a square e raised to power minus a cancel, minus 2 minus 1 over a square e raised to power minus 2. This is upper limit minus lower limit. This 0 makes this 0, minus 1 over a2 e raised to power 0. That is 1. So I can write minus is supposed to be minus 3 by a2 e raised to power minus 2 minus and minus and plus 1 over a2. We can take this as common, because here again we have to find the exact values. So 1 over a square is it as it is. So 1 minus 3 e raised to minus 2. So this comes to be, further simplified form can be 1 minus 3 over e raised to power 2, or e raised to power 2 minus 3 over a2 e2. This is the final answer, exact form. I hope it is clear. Let's proceed to the next question. A variable external satisfied differential equation, that is dy by d of x, given to be x e raised to power y minus x and x y 0 x 0. Solve the differential equation obtaining expression of y in term of x. 7 marks question. Easy question. Only you need to keep the indices rule in your mind, and this will be written as x e raised to power y into e raised to power minus x. Now make a separable terms. We will get dy over e raised to power y equal to x e raised to power minus x and d of x. Now we can integrate this. This will be e raised to minus y dy x e raised to minus x d of x. Here we will apply the integration by parts rule, by keeping in mind this, that u will be the first function, v will come here, and let's see, and this integral will be minus e raised to minus y equal to u integral of v e raised to minus x over minus 1, that is minus 1 plus differential of u will be x is 1 and e raised to power minus minus plus minus fx d of x. Further differentiation, minus e raised to minus y minus x e raised to minus x minus e raised to minus x plus c. So at x is 0, then y is 0, we will get e raised to minus 0 means minus 0 means 0, right? Equal to x is 0, this whole term 0 minus e raised to power x 0 0 plus c. We get c is equal to 0 because e power 0 is 1, so 1 on either side, it will be cancelled out. C is 0. So finally I will write, we have to write the term y in term of x, okay, minus e raised to power minus y equal to minus x e raised to minus x minus e raised to minus x. So by e raised to minus y equal to, taking common e raised to minus x, we get x plus 1 e raised to power minus x. This minus goes with this, okay. E raised to minus y equal to x plus 1 e raised to power minus x. As we have to finish our answer in y in term of x, so taking natural log on either side, so natural log of e raised to minus y equal to natural log of x plus 1 times e raised to power minus of x. Minus y will be natural log of mm, x plus 1 over e raised to power x, and this minus goes other side, minus log of x plus 1 over e raised to power x, or this can be written as log of x plus 1 over e raised to power x whole power minus 1, reverse property of log, or we can further write it as natural log of ex over x plus 1. I hope it is clear. This is the basic formation of the 7 marks question. A part done. Okay, here find the value of B part says y when x is 1, giving you answer in the form this one. Okay, this is 1 marks question. So in the from part A we did log of e raised to power x over x plus 1. Now at x is equal to 1, so y will be log of e raised to power 1 over 1 plus 1, right? I can write it as log of e by 2. So y equal to, apply the log property, log e minus log 2, and you know log is 1 and minus log 2, which is a required form, which is the required form of y equal to a minus log b, where a is 1 and b is 2. I hope it is clear. Okay guys, in question number 8 says it is taken from the vector. The point ABC have position vector OA, OB and OC, where O is the origin. The line L1 passes through B and C. It means the line L1 passes through B and C. So direction vector of line L1, that means from BC, will be OC minus OB. So because it passes through B and C, first B then C, so OC is what we are given here, 8I plus 5J minus 3K. Okay, this is OC minus OB. OB is 5I plus 2J. We can simplify this to get direction vectors is 3I plus 3J minus 3K. These are the position vector of BC. So the line in vector form, this is line R is equal to, because going through B and C, so OB first point plus lambda and position vector of BC, that is BC. So I can write as OB. OB is 5i plus 2j plus lambda. BC is 3i plus 3j minus 3k. This is the vector equation of the line. This is 3 marks. I hope it is clear. Next part, B says, then the line L2 has equation this. Find the coordinate, the point of intersection of line 1 and line 2. So it is very much clear in the concept, and in the vector video I have explained you, whenever we are given two lines and we have to find the point of intersection of the two lines, then we first write both of the lines in their parametric form. So for line 1, I can write the parametric form. R is xyz, is 3 dimension, in column vector 5 2 0 plus lambda 3 3 and minus 3. So I can write x, y and z as 5 plus 3 lambda, 2 plus 3 lambda, and 0 minus 3 lambda. So it means x coordinate of the line is 5 plus 3 lambda, y is 2 plus 3 lambda, and z is minus 3 lambda. This is, I can say, okay, equation number 1, 2 is 3. Similarly, we can write the line 2, which is given, line 2, it is given here. I will write it in column vectors. X, Y, Z is minus 2, 1, 4, plus say it's n parameter scalar multiple is n here. Suppose t n, n is given, so I will 3, 1 and minus 2. So it will be x, y, z here, minus 2 plus 3n, 1 plus n, 4 minus 2n. Okay, so here by writing individual x, y and z coordinates of the line, minus 2 plus 3n, y will be 1 plus n, z will be 4 minus 2n. So this is 4, 5 and 6. So now by comparing x, y and z coordinates, of both lines, we will get, like if I say 5 plus 3 lambda equal to, it will be minus 2 plus 3n. So 3 lambda will be minus 7 plus 3n. One form is this in term of lambda and n. And when we compare the y coordinates, we get 2 plus 3 lambda is equal to 1 plus n. So 3 lambda is equal to n minus 1. So no need to, if we compare this one, the third, minus 3 lambda equal to 4 minus 2n. Okay, we will equate the first two like this with each other. 3 lambda will be, I can write minus 7 plus 3n equal to n minus 1. So 2n equal to 6, n will be 3. And by substituting this in anywhere with lambda, we will get 3 lambda is equal to minus 7 plus 9. 3 lambda will be 2, lambda will be 2 by 3. So now we got the values of n and lambda. Now do substitute these n and lambda in anywhere in equation 1, 2, 3 or 4, 5, 6. In any one line, we will get the point of intersection. Therefore, required point of intersection of lines L1 and L2 are, say, x, y, z. If I replace n3 or lambda 2 by 3 anywhere, is depend upon either you can replace the value in this set or in this set of the line. Select any set and replace it, you will get the same answer. So x, y, z, if I put this one, so n is 3, 9, it will become 7, and it's 4, it's minus 2. This is the point of intersection. I hope it is clear. Let's go to the last part of the same question. Okay, in the C part, the point D lies on L2. So it means direction of vector of line 2 will represent the direction vector of D. So here we will write, and given that AB is equal to BD, so AB is equal to, first we will get AB because it will be OB minus OA, and we will see 5I plus 2J minus into minus 2I plus J plus 4K. This was given here in the statement of question. OA, OB and OC was given, so I wrote it from here. So we'll get 7I minus J minus 4K. This is AB vector. So the magnitude of AB will be the square root of the sum of square of their coordinates, 7 square plus minus 1 square plus minus 4 square. I will get 49 plus 16 plus 1, that will be 66. Here, since D lies on line 2 is given, therefore OD is the point that lies on, that's the same as line L2. Point on L2 is what? Here we have this point on L2. So minus 2 plus 3n, I will write minus 2 plus 3n, and then 1 plus n, 1 plus n, and 4 minus 2n. Okay, because they have the same direction vector. So BD, we know BD will be OD minus OB. So OD we have minus 2 plus 3n, 1 plus n, 4 minus 2n, and minus OB in vector form we have 5, 2 and 0. 5, 2 and 0, and after simplifying I'll get minus 7 plus 3n, n minus 1, and 4 minus 2n. Okay, so magnitude of BD will be the square root of these components, minus 7 plus 3n whole square plus n minus 1 whole square, 4 minus 2n whole square, square root, and it is given that okay, AB magnitude is equal to BD. So I will equate the result. AB is square root 66 and BD is minus 7 plus 3n whole square plus n minus 1 whole square plus 4 minus 2n whole square, square root. So simplifying will give me the answer in the form of, I will get 14n square minus 16n equal to 0. So taking an n can be 0 or n can be 30 by 7. So finally OD, because not as starting from 0, so I will ignore this. I will take this n 30 by 7 and placing here OD, yes, here, because we are looking for the position vector of D, OD. By placing n here, I will get 76 by 7, 37 by 7 and minus 32 by 7. That is the position vector of D. I hope it is clear. Okay, here the question number 9 says, this is question number 9. The polynomial we have p of x is equal to, in term of a and b, ax cube plus x square plus bx plus 3 as denoted by p of x, and it is given that p of x is divisible by this one. So it's divisible, it means remainder is 0. So I will do this long division here, or I can do the remainder theorem is same. It's my choice. Choice is mine. I think it's better to go with the other put remainder 0. Substitution is 0 because it's divisible. So x will be 1 by 2. So p of 1 by 2 is equal to a into 1 by 2 cube. Because if you go with the long division, it might be a little confusing the calculation, so student can stuck somewhere. So better to go with this method, because it is divisible, so remainder will be 0. So plus 1 by 2 whole power 2 plus b into 1 by 2 plus 3 and equal to 0. This becomes a by 8 plus 1 by 4 plus b by 2 plus 3 by 1 equal to 0. Multiply each term with 8 plus 2 plus 4b plus 24 equal to 0. I can write a plus 4b equal to minus 26. This is the equation number 1 in term of a and b. Similarly, it's also given and that when p of x is divided by x plus 2, the remainder is 5. Now put x plus 2 equal to 0 mean x equal to minus 2. I will get p of minus 2 equal to a times minus 2 cube plus minus 2 square plus b times minus 2 plus 3, and that will be equal to 5, not 0, because not divisible. It said remainder is 0. So minus 8a plus 4 minus 2b plus 3 equal to 5. I will write minus 8a minus 2b equal to minus 2. Once 4 and 3 goes the other side, become minus 2. I can divide with minus 2, become 4a plus b equal to 1. This is equation number 2. Now by solving 1 and 2 simultaneously, if I multiply this equation 2 with minus 4, I will get minus 16a minus 4b equal to minus 4, and the equation number 1 was here a plus 4b equal to minus 26. In addition comes minus 15a equal to minus 30, so a goes to be 2. And while substituting the value of a in any one of the equation, say in 1, I will get 2 plus 4b equal to minus 26, 4b equal to minus 28, b equal to minus 7. These are the values of a and b what we are looking for. And finally, here question number 10. The equation of the curve is this. Show that dy by dt is this. Okay, so implicit function. So d by d of x cube plus d by d of x of 3, we can take it common here. I can write 3 outside. X square y minus d by d of x of y cube equal d by d of x of 3. I did the steps. Now apply the rule. It will be 3x square plus 3 2xy plus x square dy by d of x minus 3y square dy by d of x equal to 0. So keeping dy by d is one side and rest of some other side. 6xy plus 3x square dy by d of x minus 3y square dy by d of x equal to 0. So here take dy by d is common. 3x square minus 3y square, and take these two terms on other sides. Minus 3 common, x square plus 2xy. So dy by d of x will be minus 3 times x square plus 2xy over, if you take 3 common while dividing, x square minus y square cancelled. So x square plus 2xy, and this minus, because this is minus, so if you take minus from the denominator as a common, it becomes cancelled, it becomes plus. So y square minus x square instead of x square minus y square, which is the required proved. I hope it is clear. So finally, it is again find the coordinate of the point on the curve where the tangent is parallel to the x-axis. Okay, this final part of the question says find the x coordinate of the point on the curve where the tangent is parallel to x-axis. Parallel to x-axis means at x-axis gradient is 0. So dy by d of x we put it equal to 0. So it means x square plus 2xy over y square minus x square is 0. So after cross multiplication, we get x square plus 2xy equal to 0. So here, so x is common, x plus 2y equal to 0. So x is 0, x equal to minus 2y, because x, if x is 0, so dy by dx will be 0, so it is not possible, so we'll ignore this one and we'll take this relation in the original question, that is x cube plus 3x squared y minus y cube equal to 3. So at x is equal to minus 2y, I will replace this 3 into minus 2y square times y minus y cube equal to 3. Simplify, it will be minus 8y cube 12y cube minus y cube equal to 3. 3y cube equal to 3. So y cube equal to 1. Y will be 1. So do replace it here. X will be minus 2 times 1. X will be minus 2. These are, therefore the coordinates of the points are minus 2 and 1 on the curve where the tangent is parallel to the x-axis. I hope this is a simple question, 5 marks question. It is clear. This was the whole paper which has been asked for the mid-year December 2024. I hope it is clear. Good luck, guys. See you in the next video.